In today's video, we're going to talk about probability and the addition rule. Two events that cannot happen at the same time, therefore do not have any common outcomes, are said to be mutually exclusive. So let's determine if an event is mutually exclusive. Okay, Han draws one card out of a standard deck of cards. Determine whether the events are mutually exclusive. He pulls an ace or a 9. Those have no overlap, so these are mutually exclusive. A king or a club. Those are not mutually exclusive because the clubs contain a king, so there's an overlap here. Okay, so you try and determine if these events are mutually exclusive. An even number or a heart, there's an overlap there, so those are not mutually exclusive. A black card or a diamond, those are two separate, there is no overlap, so those are mutually exclusive. The probability of mutually exclusive events is simply the sum of the two probabilities. So at the ballpark souvenir shop, there are 15 posters of the first baseman, 20 of the pitcher, 14 of the center fielder, and 12 of the shortstop. What is the probability that the fan choosing a poster at random will choose the poster of the center fielder or the shortstop? Well, there's no overlap there. The center fielder, there are 14 posters out of the 61 if you add those numbers up together. The shortstop, there's 12. So the probability is going to be 26 out of 61, or 42.6%. What is the probability of selecting a cat or a dog at a shelter that has 15 cats, 25 dogs, 9 rabbits, and 3 horses? So we have 15 cats out of 52 total animals, if you add those up. We have 25 dogs out of the 52. So our probability is 40 out of 52, which is a 76.9% chance that you get a cat or a dog. All right, you try the next two. All right, in the first scenario, 8 of the 28 objects are CDs, 6 are DVDs. Add those together to get 14 out of 28 equals 50%. Two dice are rolled. What is the probability that you get doubles or that the sum is 9? I did this little chart here just to illustrate the different outcomes of rolling 2 dice. The doubles, there are 6 of those. Okay, 1, 1, 2, 2, 3, 3, 4, 4, and so on. For the sum is 9, that's going to be if you get a 3 and a 6 or a 4 and a 5, but that can happen either you get a 4 then a 5 or a 5 then a 4. So this diagonal here represents those outcomes, of which there are 4. So we get a total of 10 of the 36 are possible. In the scenarios where there is an overlap, we call those not mutually exclusive. Okay. So in this case, the probability of A or B, if there's an overlap, we're going to do the probability of A plus the probability of B, and then we're going to subtract the probability of both of them happening, because we would have included both of them, we would have included it twice. So let's look at this in a scenario here. A street vendor is selling t-shirts outside the concert arena. The colors and sizes of the t-shirts are shown in the table. If the vendor randomly selects one of his shirts to put on display, what is the probability the t-shirt he selects is blue or large? All right, let's look at the chart. So this is going to be the probability of blue minus the probability, or plus the probability of large, minus the probability of B and large. Okay, so the probability that it is blue, if we add these up here, this is 15 out of the 45. The probability is large is the sum of these, which is also 15. Okay, but we've included the blue large ones twice. We've included the blue large ones here and here. So we need to subtract out the blue large. which gives us 30 minus 5 is 25, 45, which is 50.6%. Okay, so you try red or small. Okay, there are 15 reds. There are 5 smalls. The overlap is 1 red small. The other way you could do this is simply just add up this, and then you get the right, you'd get 19. But that's up to you. Right, so now we're going to decide, is the event mutually exclusive, and then find the probability using either the first formula we talked about or the second. So spinning a 3 or an odd number on a spinner with 8 equally sized sections. So if I've got a spinner with 8, 1, 2, 3, 4, 5, 6, 7, 8, 3 and odd has an overlap, so these are not mutually exclusive. Okay, and really this probability I'm just going to count. It's going to be, if I get a 1, a 3, a 5, and a 7, that is 4 out of 8, or 1/2, or 50%. Okay, from a grab bag, a birthday child gets to randomly pick one of 20 envelopes, 10 which have the toy store discount coupons, 8 which have gift cards, and 2 which contain cash. What is the probability the child selects gift card or cash? These are mutually exclusive. So we simply just add the probabilities together. So there are 8 gift cards of the 20 objects and 2 cash. So we get 10 out of 20, which is 50%. All right, your job is the last 2. All right, Madeline just purchased a new magic set. One of the tricks involves a volunteer selecting 1 card out of a standard deck of cards. So what is the probability the volunteer randomly selects the Queen of Hearts or an ace? There is no overlap there, so those are mutually exclusive. So there's 1 Queen of Hearts out of the 52, 4 aces for 5 out of 52, which is 9.6%. The probability of a black card or a king, there is overlap there. So there are 26 black cards, there are 4 kings, but we've counted the black kings twice. So we subtract 2 out of 52 to get 28 out of 52, which is 53.8%. So that is probability and the addition rule.